Hello, everyone, and welcome to our webinar. I'm Joe Goldberg, and I'm joined today by Basil Faruqi. We're both members of the Control-M Solutions marketing team. I believe our topic today will be very relevant for almost every organization that's working to extract business insights and quickly deliver customer value out of our ever-increasingly instrumented world. The technologies that are being leveraged to achieve these goals are big data, which consists of Hadoop and its ecosystem to process the massive volume of data that's being generated by our society. Cloud is providing efficient and cost-effective elasticity and computing resources at the push of a button. And a DevOps approach is being taken to delivering new applications in the shortest amount of time with the highest level of quality by leveraging automation. We will be describing how an application orchestration solution helps to implement an automated IoT pipeline for predictive vehicle maintenance. But of course, a very similar approach can be used in a vast variety of use cases, including smart metering, asset management, and even improving the quality of grapes for superior wine. Basil, can you perhaps describe for us the use case that we're going to be talking about and demonstrating today?
Sure. Thank you, Joe. So as Joe mentioned, the focus of the use case in this demo is going to be the scenario of a company that owns hundreds, perhaps thousands of vehicles, in this case trucks. And like in many industries, their goal is to minimize the downtime of these vehicles for obvious reasons. An emergency repair on a vehicle that's carrying freight is a lot more costly than doing scheduled maintenance, much like we would face that situation in our personal lives with our own cars. So the business goal is really they want to cut down this vehicle downtime by 40%. The technical requirement at a very high level here is that all of these trucks are instrumented with sensors, and they want to analyze the data from these sensors and apply machine learning to this to be able to then predict a possible failure and schedule preventive maintenance. Let's look at a little bit of the details of what this looks like. So the core of this program is obviously the machine learning algorithm that will do all the processing. But what becomes very clear when you look at this from the lens of how will you orchestrate all this activity, that there's a lot more to it. And what you see on the screen now is the demo architecture. So like Joe mentioned, we have IoT data that we want to leverage. We want to use cloud, given its elastic nature and the auto-scaling capabilities that come there. And then obviously we want to notify the relevant people, in this case perhaps the driver of the truck driver, so that they can take the truck to the nearest service center for repairs. So what you see on the screen now is the flow that we will orchestrate. We will be dynamically provisioning an EMR instance on AWS. For those of you who may not be familiar with EMR, it's a Hadoop distribution that's offered by Amazon Web Services. And Control-M agent, which is going to be provisioned as part of the instantiation of the AWS environment. And once the infrastructure is provisioned, we're going to transfer the data there, which is going to be the vehicle sensor data, and Spark in this case is going to be used to process the data. And since we're going to be decommissioning this cluster, we're going to take this data out of that cluster before we decommission it, alert, notify, and finally we terminate it. So as I mentioned earlier, while the core of this seems like it's all machine learning, it becomes very clear that it is only, when you think about running this at scale and in production, that is only one piece of the picture. And what's going to orchestrate all of this activity from start to finish is Control-M. And you will see that live in the demo here in just a minute. Head and switch over to my demo environment.
Basil, I hope before you start this demo that we make a small sacrifice to appease the demo gods, because this is a real demo as far as I understand. Is that correct?
Yeah, that's exactly right. And, I have my fingers crossed like I always do before any live demo. So the entire instantiation of the cloud environment and processing of the data and then termination of the cluster is all going to happen live here. And we will try and pause and highlight those elements so that you can recognize that this is all happening live here. Okay. So what you see on the screen right now is the Control-M interface, and what I'm going to do is I'm going to go ahead and go to the order service capability here, which will allow me to order the entire orchestration of all the events that I showed you on my demo slide. And in this case, I want the notification to go out as a text message, so I will go ahead and add my phone number for that purpose, and I go ahead and click on order. And what you see here now on the screen is that an IoT pipeline has been submitted. I have clicked on the wrong one here. Here's the IoT pipeline that actually got submitted. The first one was the submission one. So what you see here is a series of tasks or jobs that represent the demo architecture I had shown you earlier. The first one here is going to be creating the cluster, as the job name suggests here. It's going to be instantiating the Amazon AWS EMR environment, and I will actually switch over to that AWS console here in just a minute. Once that is done, we will be customizing and deploying what is called a connection profile for the control server to be able to connect to this environment, and followed by the setup of a jar file and copying the maintenance data there, reading the CSV format, and then a couple of other steps before we notify and then terminate the cluster. Now, let me actually quickly switch over to the AWS EMR environment here that I have open to see if we have the cluster. So you can see here that the cluster has been started, it's instantiating, and it's in starting status. If we go back to the pipeline service, you see that the job is yellow, which indicates it's still running. There's a series of steps that it needs to complete behind the scenes before the cluster is fully provisioned and ready to go. Now, the benefit of Control-M here is obviously that the visualization layer, number one. You can see this entire pipeline and its current status in a very, very intuitive manner. And I'll come back to this, but the logs and output are all available from one interface. But before I do that, it's important to take a step back and think about the kind of the DevOps element of this, that when a developer was writing the machine learning aspects of it and the code, and we'll describe that in some detail as well a little bit later, traditionally, developers have built these types of applications, and they may have worked on them for weeks, perhaps months, and at some point they would hand this stuff off to a team that is responsible for productionizing this. Generally the IT ops teams. But as we think about doing these types of projects with speed and quality, it's imperative that majority, if not all, of the elements of what is required for the application to be successfully running in production are included at every stage of development and testing. So to that end, let me just first quickly show you the GitHub repo where all of this code is stored, the machine learning aspects of it. So there's the Scala programs that you see, and several other, the make prediction, the pipeline, and all of this, the machine learning aspects. So that's what a core developer would focus on. But as we can see, for this to be able to run successfully and scale in an environment like this, you need to build the orchestration logic as well. And What you see on the screen now is an approach that we here at BMC in the Control M business call jobs as code. So just like a developer has written all the Scala code, they should be able to, in simple code language, write the entire orchestration logic. So all of those jobs that you see on the screen here were created using JSON format as the application was being developed. So just a quick deconstruction of a couple of jobs here. The top section is default, which defines some of the defaults that will apply to all of the jobs in this pipeline. And the rest of this is very, very human readable, description of what this folder is, what the high level folder is doing. Then we start looking at some of the jobs inside of it. So this is really in code format. The first job on the screen that you see running currently is that we are going to go ahead and, launch an EMR cluster and deploy a Control M agent on it so that Control M can then orchestrate the rest of the activity. And so you can go ahead, Joe.
So, just for a question that the audience may have, what kind of a language is this? Is this something that developers would be familiar with, or is this something very specific to Control M?
So that's a great question. This is a JSON format, which is JavaScript object notation, and almost all developers that I have come across in the last few years are very, very familiar with this. So this is certainly not specific to Control M, and JSON was picked as the format given the wide adoption amongst the developer community. So as you can see here, this was built, and as the Scala code was being developed, this entire orchestration logic can be developed in code. Now, another big benefit of jobs as code is that when you think about the modern delivery mechanisms of CI/CD, the application logic and the orchestration logic can be pushed through a CI/CD pipeline in an automated way, and the tool chain inside the CI/CD pipeline for Control M, we're completely agnostic to that. So think of a workflow where you would commit the application code to a repository like Git, and then a build tool like Jenkins will go ahead and initiate the build, and maybe something like a Chef or Puppet will handle the instantiation of the infrastructure. So when you have the orchestration logic in code format, it allows you to push this through a CI/CD pipeline. Now, let's go back and see how are we progressing on our pipeline. So this first job, which does most of the heavy lifting here, other than the Spark job that does some of the machine learning stuff, it takes about 10 minutes to run, so it's still running here. Another important aspect to talk about here is that Control M has been instrumented with what is known as the Automation API, and this API provides a layer of abstraction to the developers and other individuals who want to interact with Control M without really having any Control M infrastructure really installed on their particular laptops or endpoints. And I'll talk about that here just a minute on what that looks like. But the Automation API it's a REST-based API. We have provided a Node.js CLI as well, which I will showcase here in just a minute. But it's important to highlight here that all of Control M's functionality is exposed through REST API, and you can programmatically interact with an automated pipeline like this, where let's go ahead and take a look at what the log looks like. So what you see here is the log of a Control M job, and you can see when it was ordered, the users that ran it. And let's take a look at what the output looks like. So it's still running. It hasn't really created the output, but we will come back to it. Let's go ahead and let's go ahead and try and refresh this. This is so you can see that the status has updated. It is now in bootstrapping stage. And this is actually really the stage where the Control-M infrastructure is going to get instantiated as well. And let's take a look at
So, Basil, in this flow that we're watching, we're creating or instantiating this EMR cluster. Do you want to talk a little bit about why someone would want to create a cluster perhaps each time? What would be the benefit of that as opposed to having a static cluster that we use on a regular basis?
That's actually a very good question. And so while cloud provides a lot of elasticity and easy access to compute, when you think of the cost model of the cloud, you're paying by the minute. And in fact, now in some of the billing models, you're literally paying by the second. And when you throw a lot of compute and you instantiate a lot of these environments, to optimize the cost, it is advisable to terminate these instances when you are no longer using them. So if we think in the case of predicting the failures, when you have kind of maybe microbatch the data, a lot of times the data is being streamed into a telematic provider. The telematic provider will microbatch the data and provide it to you for analysis. And that's where you may want to instantiate the cluster, process the data there, and once you're done with the processing, you bring down those resources so you're no longer paying for the compute that you're no longer using. Okay, so let's go back to our, so we can see that the cluster job has now completed and we are now on our way to the next job here. So let's go ahead and see if the output is complete. So you can see here that, let me see if I can expand this a little bit. So I can now see the output of this job, and I can see that from the Control-M interface without actually having to log in to CloudWatch or the actual endpoint or server where the job ran. Now this is very, very important from an operational capability. When you are, this flow is, while we have tried to mirror a real life situation, it is still rather simplistic. For example, in a real world, not only would you want to process the sensor data, but you want to marry that data with some maybe parts and warranty data and other environments that may not be sitting in the cloud. They may be sitting in a legacy system that is on-prem, and some of that data will have to be brought into the Hadoop environment and collated and whatnot. So when you are looking at multiple systems, multiple applications, and you're orchestrating a complex pipeline, every time you're trying to troubleshoot or look at log and output for whatever reason, it becomes quite challenging if you have to log into every system where individual jobs ran. So that's definitely a huge benefit that you get with Control-M. And as I had mentioned earlier, the rest of the flow runs fairly quickly. Let's actually look at the output from a few other jobs here. So this is one of the jobs that ran and set up the jar file, and you can see here's the output that we can see here. This job here is actually the Spark job, and it's a Hadoop job that was run through Control-M. So you can see that the job before was actually a file transfer job and has actually transferred the data to this environment after the infrastructure was available. This is a job that is now processing the log and output here. So it makes it very, very convenient from an operational perspective to interact with multiple jobs running across multiple systems and applications from a single interface.
Hey, Basil. So this looks pretty good. I think it's really great. But if I'm a developer or if I'm building that automated pipeline that you were mentioning, and I need to perform these kind of functions in some kind of an automated way, obviously the graphical interface is now what I would use. So are these capabilities available programmatically as well?
Yeah, it's a great question. And again, as I mentioned earlier, that we have exposed a lot of the Control-M core functionality through a REST API, and we also provide a CLI, which is a very, very common approach. You see AWS and other cloud vendors doing the same thing, where you can access their services through REST API directly through Java code or Scala code, or there's an AWS CLI available as well that you can download, and that makes it a little bit easier for you to interact with that. So what you see on the screen now on the command prompt is I have the Automation API CLI installed on this environment where I'm running this demo, and just simply typing CTM gives you a list of a lot of the different control and capabilities that are exposed through the CLI and API. So build will be able to validate the jobs as code or the JSON format that I showed you earlier. There's configuration, deployment, and many others. So let's actually go ahead and take an example here. So if I look at this read CSV job, the Hadoop job, it's given me an order ID. And if I wanted to interact with this programmatically, let's see, I had one in my buffer, so I'm going to go ahead and paste the order ID here. So I'm simply going to go ahead and try and, through command line, look at the log of this job. So as you can see, this is returned here, and for the purposes of the demo, I'm running this interactively on the CLI, but this entire same command could be called programmatically through an API of another program. Okay, and if we just look at simply the run options under this, and here's a list of a lot of different actions that are available programmatically. So being able to free a job, being able to hold a job, being able to abort the execution, all of these things are almost guaranteed events in a day-to-day operations, right? So you may need to hold a job, may need to kill a job, may need to rerun a job, may need to retrieve the output of a job, and if the visualization is definitely great through an interface like this, but like you said, Joe, there may be several scenarios where it's more desirable to interact programmatically. Okay, so this flow has now completed, and the last job here, the notify, by the way, is the job that was actually going to send a notification through SNS, and a truck driver in this case would receive the notification on their smartphone as a text message, and it would direct them on what the next action is here. Now, I want to spend just a minute talking a little bit more about the machine learning. So if there's any data scientists or machine learning professionals who are listening to this, the entire machine learning code is actually available on this GitHub repo here. So you can see the link for the entire code. But this is obviously simply just the code. This is also documented in a blog, and the link that you see here on the screen now is a shortened bit.ly link for that, and let me just pull that up. So what you see here is a lot of detail on the machine learning aspect of it, the architecture, the training model, the actual code sample here. So for anybody who's interested in diving deeper into the machine learning aspect of this and the training of the model, they could go ahead and take a look at this blog here. Okay, so the last job in this pipeline was the one that terminated the cluster. So let's go and actually verify if the cluster has now been terminated. So as you can see here, the FY19 seminar demo is now being has now been terminated based on user request. And as you can see, in preparation for this demo, we tested this multiple times, and you can see the previous clusters that we instantiated and terminated as part of the prep. And this was a relatively small data set, and you can see kind of in a space of 13 minutes here, we have taken some, instantiated not only the EMR cluster, the Control M components of it, and moved the data there, processed the data there, notify, send out notification, and then terminated the cluster. To our presentation here. So again, just to recap, this is the architecture that you just saw in the demo, and what orchestrated this from start to finish was Control M.
Oh. Well, I hope everyone on the webinar is as impressed as I was. I think that there's some tremendous information here, and for anyone who has found this interesting, there's lots of additional resources to help you get started with Control M. You can go to a website called jobsascode.io. That's all one word without any punctuation. See that on the slide in front of you. And at that site, not only is there a lot of information about how you can get started, additional use cases, some other examples of what customers are doing, but you can also pull down a free development environment for Control M called Control M Workbench to help you get started. And so what you have seen, the work that was created to build the flows, run this kind of an automated process, you can do this on your own, in your own development environment, probably within about 10 to 15 minutes of getting started. So thank you very much for listening to our webinar, and we hope that all of you visit jobsascode.io to learn more about Control M. Thank you and goodbye.